बेस्ट टीचर्स के गाइडेंस में पढ़ना इजियर होगा। एग्जाम या हो लाइफ, अब से हर स्टूडेंट विनर होगा। समझ आएगा तो मजा आएगा। Vedantu, learn live online. To attend a free live class, download the app now.
Hello everyone. Good evening. Hi Sarah. Hi Hardik. Very less number of people it seems. Rajna, Shruti, Rex, Snehanchali. So tell me, how are you all doing in this very fine evening? Tell me, how are you all doing? Hi Rachna, Radak, Lakshmi, Gangandeep, Jyoti. Okay, now I can see the crowd. Okay, I'm so happy with it. The chat is being flooded. So tell me, I'm again asking, how are you all doing? Yes, I'm a Malu. Who asked me? Yes, I'm a Malu. I'm from Kerala. Okay, precisely if I talk about, I'm from Calicut, if you know the place. All good, happy? Right. So I hope you all are doing good and doing very hard for your exams which is coming, right? Okay. So that's what I want. So those who don't know me, myself Ameer Basit, Master Teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics, right? Okay. So today an incident happened. So some teacher came to me and told that this year onwards in this question paper, CBSE board question paper, multiple choice question is gonna come, right? Which means objective question is gonna come. Then I was thinking about all my students, right? All my YouTube students, all the students in the country, okay, which I am having. Then I thought, why I have to worry about it? Okay, why my students have to worry about it? Because we are doing the multiple choice question series or MCQ series over here, right? So by the end of the series, you are going to be super awesome and gonna get the full marks in this particular series or in all the objective questions, right? Okay, so let's start this particular series for today with that beautiful theoretical chapter, Wave Optics. So tell me, are you all ready and excited for this particular chapter? Hi Anita. Tell me, are you all excited? Okay. Yes, we'll start. Don't worry at all. Okay. Okay, let's go. So before starting with the session, I have to tell you this thing, guys. If you are having any trouble with any particular chapters, which means if you are not able to understand the theory of any particular chapter, you can come to the Vedantu side and you can buy the particular chapter, which means the particular micro course. And how much you have to pay? How much you have to pay, guys? Just 1 rupees. How much? Just 1 rupees you have to pay for all these things. I know that you can pay and you can get the courses from all the teachers. Then also it will be costing like 100 rupees only, right? Okay, just 1 rupees. Okay, so let's not waste our time because we have got a lot to learn. So let's start, right? Okay, so you can give your answers in the chat box. I'll be looking to it and within the time I will also be doing it, those who don't know how to do it, right? Okay, so let's start doing it. Half an hour complete question, right? Looking handsome. Thank you so much. Okay, so first question, when interference of light takes place, what is happening? Interference, you know that from two slits energy is coming or the light is coming. Okay, so when the light comes at particular point, constructive interference happens, bright points happens, right? And in some point destructive interference happens, which means dark points. Okay, now you may think that at the destructive points where there is no brightness or there is no light, you may think that the energy is getting destroyed. No, energy can never be created nor be destroyed. So what is actually happening there? So the energy which was there with two slits, okay, or the two light rays coming from two slits, okay, so the energy which is getting redistributed actually, right? Whenever the energy is getting less over the destructive part or destructive interference part, that energy is given to the constructive interference part, right? Okay, which means the energy is actually getting redistributed. It is not what? It is not the construction or the destruction of the energy is not happening. The energy is only redistributed, right? So which option we can go for? Okay, I'm really sorry. Okay, so I hope you can see the slides now. Energy is not created in the region of maximum intensity. Energy is not destroyed. What is actually happening? Actually, what is happening? The energy is getting just redistributed. That's all. Right? Yes, very good. We can go for the option C. Conservation of energy is held everywhere. Very good. Thank you so much for this lovely reply. and making this chat and this class super special and active. Next question. The phenomenon which is not explained by Huygens construction of wavefront. Which is the one? Reflection, can it explain? Huygens principle mean it corresponds mainly wave nature of the light, right? Okay, what is being explained in Huygens principle? The wave nature of the light. Because of the wave nature of light, we can explain reflection, right? Yes, we can explain diffraction, we can explain refraction. But what about origin of spectra? Spectra, okay, do you remember emission spectrum and the absorption spectrum? This spectrum or the origin of the spectrum is actually explained on the basis of what? The quantum mechanics, or on the basis of photon nature of light or the particle nature of light, right? Okay, so this Huygens principle, which is based on the wave nature of light, cannot explain the origin of spectra, which is actually based on the particle nature of light, right? So which option? Which option? Which option we can go for? We can go for the option D, right? Good? Happy? No, you are not late, Optimus. Okay, we just started and this is the second question. We have lot much of questions, right? Yes, very good. Next question. For light diverging from a point source. For a light diverging from a point source, the wavefront is spherical. Okay, what is the shape of the wavefront is what they are asking. Okay, for a point source, what is the shape of the wavefront? Guys, do you know what is called as a wavefront? Wavefront is defined as the locus of all points which are at same phase, right? Okay, so if you take a single point, look, let me draw. So if you take a single point like this, and if you start marking all the points which are at same phase in a 2 dimension, it will be coming as what? It will be coming as a circle. Same phase means same angle, right? So these 2 points are at same phase because they are almost at the crust of it, or you can say that the phase of both these waves are pi by 2, right? Okay, so if you take a particular point and take the locus of all points which are having the same phase, it will be coming as a sphere, right? So it can only be explained in a 3-dimensional space. Okay, and I'm not able to just on this 2-dimensional space. I can explain what? I can show the circle only. So actually it is not circle, the wavefront is spherical in nature. So option A, right? Understood? Everyone happy? Hyperbolic? No, not at all, not hyperbolic. It is just spherical, right? Okay, from a point, you think what is the shape you will be getting if you take equal distance from a point? What is the shape you are getting? You will be getting a spherical shape only. Very simple it is. You don't have to think that much. Guys, happy? Give me a smile then if you guys are happy. Give me a smile. It is not hyperbolic at all. In most of the case, it is not going to be hyperbolic. Maybe in some complex structures and all. Okay, so not in this case. My English is awesome. Good, thank you so much. Okay, so why the slide is not moving? Okay, now it is moving. Yes. Polarization of light proves what? What is it actually proving? Can you tell me? Yes, very good. The chat is flooded with a smile. So let's hope this you are going to spread the smile throughout the world in your future and in your career also, right? Good. So which option? Polarization of light proves what nature of the light? Okay, you know that this light is an actually electromagnetic wave, right? If I talk about electromagnetic wave, and if I say that the energy or the light is moving in the positive x-axis, it contains electric waves like this and magnetic waves like this, which are perpendicular to each other. And these kind of waves where the displacement of the particles or the oscillation of the particles are perpendicular to the direction of propagation of energy are called as transverse waves, right? Okay, so this is rotating and the displacement of the particle is there in the complete YZ plane, right, according to this particular figure. Now if I pass this unpolarized light through a Polaroid, okay, if I pass it through a Polaroid, what will happen? The polarization of the light happens, or the what you can say? You can say that the electric field will be having a vibration only in a particular direction. That is called as polarization, and it is happening because of what nature of light? It is happening because of what nature of light? Because of the transverse nature of light, right? Good. Yes, I am a Malayali. Yes, Anand. No, we are not doing Mendy. I thought this will be more helpful so that we can cover more amount of questions. You can also do, I can also do, right? Very good. So next question. Where is our question? Yes. Resolving power of microscope depends upon. Who is going to tell me the formula for resolving power of microscope? Who is going to tell me? Who is going to tell me the formula for resolving power? I hope you know what do you mean by resolving power, right? The ability of any optical instrument to see closely spaced two objects as distinct objects. Sometimes if you keep two objects very close, you might not be able to see it differently, right? So the ability of the optical instrument to see two closely placed objects distinctly is called as resolving power. Formula? What is the formula of resolving power? What is the formula? Can you see? The resolving power of microscope is equal to 2n sine theta divided by lambda. What is it? 2n sine theta divided by lambda. So resolving power depends upon wavelength, but it is in a inverse fashion, right? So you can see the formula of resolving power. Very good. Yes. 2 mu sine theta divided by 1.22 lambda. If you want to be more specific, the equation will be more specific if you use 2 mu sine theta divided by 1.22 lambda. Good. Wow, great. All my students are learning, giving me the answers. Nainika, sodium gaming. Wow, what is it? Jyoti, Gangandeep, Tejesh. Good. Awesome. We'll do Mendy, don't worry at all. Thank you for your continuous support, sir. Thanks a lot. Thank you so much for being in my class. So I have to say that. Next, what is the path difference for destructive interference? Okay, when will the destructive interference happen? Can you tell me when will the destructive interference happen? When okay, I'll give you small explanation. When a crust and when a 1 minute. Look, when will happen? When a crust and when a trough is undergoing the superposition, right? I hope you can see that when a crust and a trough. What is the path difference? This is having what? This is having like this. So what is the path difference between these two waves? What is the path difference? It is lambda by 2. Or if it is any multiple of lambda by 2 also, destructive interference happens. Lambda by 2, 3 lambda by 2, 5 lambda by 2, because in all these cases, the superposition of a crust and a trough will be happening, so that they will be doing what? They will be what will be happening? They will be undergoing destructive superposition, or they will be cancelling to get a minimum intensity point, right? Yes, resultant amplitude is minimum in that case, right? Okay, very good, very good. So which option we can go for? Any odd multiples of lambda by 2 is this 2n plus 1 lambda by 2, which means 5 lambda by 2, 7 lambda by 2, okay, in all these cases, right? Good. So next, where is our next question? When exposed to sunlight, thin films of oil on water often exhibit brilliant colors due to the phenomenon of what? Because of what reason it is exhibiting brilliant colors? Sometimes you might have seen that if there is a oil spillage on the road, you can see rainbow on that oil spillage. What is happening, or what is the reason for it? What is the reason? It is because of the thin film interference. Do anyone know what is this thin film interference? So our actual option is where? Option A is the answer. So what is this thin film interference? Okay, listen carefully, those who don't know. Think that you are having a water over here. Okay, on this there is some oil surface, oil spillage is there. Okay, and this is of thickness T. Suppose a light ray is coming, light ray comes. When it reaches over here, this line of separation, some of the light rays will be reflected, some of it will be undergoing refraction and it will be transmitted over here. Again, when it reaches the line of separation, the light rays will be undergoing reflection and some will be transmitted. So these two light rays which are reflected back will be undergoing interference, and if it is having constructive interference, according to the path difference that it produces, it will be producing different types of colors, right? So this is what is happening, and this is explained on the topic of thin film interference, those who have seen, right? Good, happy? It is not about dispersion. This is not dispersion. Okay, dispersion happens in this case only. Look, dispersion, whenever a light is passing through a prism, it is converted into 7 different colors. right? Here only refraction is happening. Here what is happening? The interference, two light rays are getting added up. Okay, so two light rays are getting added up. Okay, which means superposition of light rays are happening. That's why it is coming under interference, not dispersion. Thank you so much, Nishar. Great. I hope you guys have understood. Polarization. Why it has to come polarization over here? What is the? I hope you guys know what is polarization at least, right? Polarization means it is a process of making an unpolarized light. What do you mean by unpolarized light? Where there is electric field vibrating in all the directions, right? Making into a single direction is actually called as polarization. Okay, it has nothing to do with interference or producing the colors. Yes, next, a double slit interference experiment is carried out in air and the entire arrangement is dipped in water. Okay, what is happening? You are having a double slit experiment. Okay, initially it was carried out in air. Okay, now if it is carried out in air, it will be producing an interference pattern. There will be having fringes and there will be width for the fringes. What do you mean by fringe width? Guys, do you know what do you mean by fringe width? Fringe width means it is the width of the bright point and the dark band which is formed. Okay, the width of it is actually called as fringe width. We are not going for the derivation. Guys, I hope everyone knows the formula for fringe width. What is the formula? Beta is equal to lambda capital D by D. It is same throughout. Okay. Now, when the entire arrangement is dipped in water, if the entire arrangement is dipped in water, the medium changes. If the medium changes, which is the only quantity that is going to change, lambda. So, when it is dipped, fringe width will change and that is equal to lambda dash D by D, and small d is going to be the same. What is the relationship between lambda and lambda dash? Guys, do you know what is the different actual how do you connect lambda and lambda dash? How are you going to connect lambda and lambda dash? Lambda dash is equal to lambda divided by lambda, which is a wavelength in light, divided by the refractive index of the medium. Very good. D by D. This is how you make the connection. So the fringe width, what will happen? Now the refractive index n is happening. Okay, lambda d by n, right? So what happened? The fringe width will decreases. Yes or no? So which option we can go for? We can go for the option B. Understood? All good? Hey, guys, happy till here, I hope? Okay. Then why we have to wait if you all are happy with the question? Where is our next question? Why I can't see? Yes. To observe diffraction, the size of the obstacle. Okay, I hope you know what do you mean by diffraction, right? Okay, the bending of the light rays at the obstacles is simply called as diffraction. You might have studied the single slit diffraction also. And in the case of single slit diffraction, what is the formula for the dark band which is formed? That is equal to, 1 minute, A sine theta is equal to n lambda, right? Okay, or sine theta is equal to n times lambda divided by A. Lambda is wavelength where A is the slit width, right? Okay, now if you know that if the theta value has to be somewhat which we can see, theta means the amount of divergence of the light ray. If it has to be something which we can see, lambda by A value also has to be something, right? It should be having a numerical value which is almost where you can see a difference, right? Okay, now if the A value, if it is greater, which means, what do you mean by this A value? If the slit width is having very much greater value, which means which is coming in the denominator, the entire n lambda by A will be very small, which means theta value will be very small, which means the bending of the light ray will be small, so diffraction won't be visible. Okay, so if the diffraction has to be visible, A shouldn't be that much greater, which means it should be of the order of wavelength, right? So which answer we can go for? Should be of the order of wavelength. Understood? Good? Happy? Next one. Where is it? Where is our next question? Yes, the angle of incidence at which reflected light is totally polarized for reflection from air to glasses. What do you call this angle of incidence? guys, can you tell me what do you call this angle of incidence? This angle of incidence is called as the Brewster's angle, right? The angle of incidence for which the reflected light ray will be plane polarized is called as Brewster's angle. And what is the relation? Who is going to tell me the relationship between the Brewster's angle and the refractive index? Who is going to tell me? Santanu, Redak, Jyoti, Sodium, Aishwarya. Who is going to tell me? Brewster's I. Very good. Who told me? Aditya. What is it? Tan of IB is equal to tan of Brewster's angle is equal to refractive index, and that Brewster's angle or that angle of incidence is equal to tan inverse of n, right? Yes or no? So which option we can go for? Very easily, just like that. Option D, right? Happy? All good? Easy peasy? Yes. So next question. The angular resolution of a 10 centimeter diameter telescope at a wavelength of 500 Armstrong is of the order. What is the formula for angular resolution of a telescope? What is the formula? 1.22 lambda divided by d, right? What is the formula for angular resolution of a telescope? I hope everyone knows it. That is equal to 1.22 lambda divided by d. 1.22 lambda, which is the wavelength. How much it is? 5000 into 10 power minus 10, right? Divided by the diameter. What is given as a diameter? It is 10 centimeters. Just apply it in the form of meters, right? 10 into 10 power minus 2. Just what we are having, just the calculation is left. Once you start with the calculation, you will be getting the answer as 6.1 into 10 power minus 6. So it is of the order of 10 power minus 6. Yes. Good. Happy. Great. So guys, I hope you are total happy with the classes. So you guys want me to make any changes in the way of teaching or in the content you want me to change, you can tell me now so that I can make the changes accordingly. Because of you, you are seeing this video, that's a great thing. So I hope you all are happy, right? Okay, that's a great thing. So I'm so happy with that. So it's a great thing as a teacher that people are there for me just because you are understanding, just because you love my classes, right? Okay, magnetism we are gonna do. Don't worry, all these lectures and all the chapters we'll be doing the multiple choice questions, right? Fitness guy. Okay, so guys, if you're having any doubts with the theory, we already have done a series, right, about the previous year question. You can see that. So the theoretical explanation for each and every question and the previous year question is done there. So you can type my name, and 12 boards previous year question is already done. So please go and watch. It will be helpful for you so that you can do a quick revision also, right? Okay, so for all these things what I have done, and if you guys have understood, then what you have to do, please move your cursor, okay, take it down and press the like button, guys. Press the like button, don't forget it. Just for all these things, for talking for half an hour and delivering all these things, I'm just asking you to put the like button. And if you think that this is helpful, not only for you, for your friends also, please share it with them. And don't forget this, the best part which is coming, right? What is the best part? Subscribe part. It is helpful for me, first of all, okay? It will be doing a lot of things, okay? And why am I asking you to subscribe? For two things, okay? To give us motivation so that I can do more and more questions for you, right? So I'll also be happy that you guys are getting interested in it. So what you have to do, press the subscribe button to know that how much you love me. And one more thing is that if you subscribe, you will get the notification from Vedantu which all videos are coming up, right? Okay. So good. So someone is telling from commerce batch also, so many are there who's a fan of me. I'm so much happy. I'm gymnastic, nothing like that. Okay, so I think it's time for me to say bye bye, good night, guys. Okay, derivation part someone is asking. As I have told you, I have already done that. Please go and watch those videos, it is already there. Okay, so bye, love you so much. So see you all. Okay, don't sleep now, take care, have food and study a lot. Okay, bye.